Thanks so much for coming, everyone. First event. Glad to see the chairs filled and all that fun stuff. I'm Christian Glasigno. I do events here at Swix. Swix is a webhook service, so you can think of it as just the best way to send and receive webhooks in a way where you'll never drop them, because services generally just send you a few webhooks for each event. And if you miss it, you miss it. That's kind of it. We also help with security kind of stuff and general webhooks. So if you have a general webhook related problem, think of Swix first, Swix.com. Here with James Cowling from Convex. Oh, that's a good idea. Record. James Brown from Swix here, and then Tejas. How do you pronounce your last name?
Siripurapu.
Siripurapu. Okay, I'm sorry if I butchered that. There you go. From Bappy, and we're learning here talking about what it is like to scale infrastructure and backend stuff at startups. It's going to be very fun. I think just as a quick way to get started, do you guys want to introduce yourselves? Start from the end.
Sure. Hey everyone, I'm James. I'm co-founder and CTO at a company called Convex. Backend as a service, we have on the order of millions projects running on us. So the whole point of Convex is to abstract away the hard problems of managing backend infrastructure. So it's a high-level abstraction for infrastructure. So the big thing, my contribution to the tech industry, I suppose, is coming up with what I hope are clean abstractions that abstract away complicated infrastructural problems. Before Convex, I was a senior principal engineer at Dropbox and designed most of the large infrastructure there. So designed Dropbox's storage system and distributed database and a lot of those stuff, and migrated Dropbox off S3. And so I've been working on large kind of exabyte, exabyte storage, petabyte metadata systems for a couple of decades.
Well, good morning, everybody. I'm also James, which I'm sure won't be confusing at all during this talk. I'm an engineer here at Swix. We are webhooks as a service, as Christian already mentioned. In terms of scale, we're a small startup. There are 6 engineers on the team. We are doing many billions of billable transactions per month, which is a lot for 6 people, especially when you start looking at the on-call rotation. Before this, I've done a whole bunch of other startups, including sort of doing all of the architecture at a place called EasyPost, which is a shipping logistics company, being one of the first engineers and the first staff level engineer at Uber, and also working at Yelp back in the very, very old days when we got to migrate from Python 2.6 to 2.7, which let me just tell you, that was a big change back in the day. So hopefully I'll be able to, provide some fun history to go along with what we're talking about here.
Cool. My name is Tejas. I lead infrastructure at Vappy. We're a voice AI platform, and we currently handle about 1 million calls, so phone calls a day on our platform, and that comes with a variety of complex infrastructure challenges. Before Vappy, I was at Amplitude, where I was doing working on their big data pipelines, and then I was at HPE, where I was working on ML and AI training abstractions on top of their supercomputing infrastructure. Yeah.
Cool. So there's a lot of different places we can get started. I think one of them would be, I think everyone generally has just been pushed more towards infrastructure these days. I think AI has kind of changed a lot of that. I think your company is definitely one of those companies where it's a lot of voice AI stuff wasn't being done before, and now we're doing a lot of it. And it's in some ways kind of for Vappy specifically, a bit of a state machine. And then for Convex, it's kind of a more general trend towards giving developers just more ways to do things. But I think one of the things that all 3 platforms do really well is just taking away some of these very hard to work around but very obvious failure cases from developers. So do you I guess we can start. I can throw out a few different ones, or do you want to start with what are some of the things that developers don't really see you guys doing on your platform, but you guys have spent a really long time perfecting?
Interesting. I think the big problem or the big pain we solve for a lot of developers, because people can use open source tools on the market to build something similar to what we do, but we solve the scaling problem. And I think that's a real, once you get to that problem of again, doing millions of calls a day, or even for an individual user, if they want to do thousands of calls concurrently at a time, being able to scale your infrastructure to meet that kind of demand is really tricky and painful. And you don't realize it until you start doing it yourself. Doing 1 call at a time is kind of simple. And then once you're doing thousands, it's doing thousands, you could probably throw a lot of money at the problem and make it a little bit easier, but doing it cost efficiently also is very challenging. And I think that's something we solve for a lot of people. Yeah.
do you want to like dive deeper into that? So like, what is the kind of like VAPI tech setup, or like,
Oh, yeah.
you know, I imagine for like phone calls specifically, or like pre-distributed kind of like compute for
Yeah.
stuff, or like
So we run entirely on Kubernetes. For those who don't know, like VAPI's platform is basically letting people make phone calls to AI assistants on the platform. That AI assistant runs in essentially a Kubernetes pod. It's like isolated from everything else. Um, so every single call that's coming in, or in reality, it's like bunches of calls now because we do concurrent call workers, but the number of workers we have scales based on the number of calls we're doing in our platform. So again, like if you're an individual user and you want to do 1,000 calls at once, you need to, if you were to do this, try to solve this problem on your own, you need to build infrastructure that can scale flexibly like that. And that's a pretty challenging problem. So yeah.
how about for Swix or in general just stuff?
Yeah, I mean, I think what Sphinx really provides leverage for is developer time. Obviously, the infrastructure matters. Obviously, nobody wants to have to spin up a ton of servers to send webhooks, but there are a lot of edge cases, and it's really enumerating those edge cases that we're trying to do. So just to provide a very simple example, I've done a lot of information security work in my life. I can tell you pretty much every company that sends webhooks will have a very bad time if you go set your webhook address to 127.0.0.1 because pretty much nobody knows how to correctly filter that. That's something that you can definitely hire engineers who know enough about security to know what a DNS rebinding attack is and how to protect against it and yada yada. But we're all here because we do stuff with startups, and engineers are the limiting reagent, and definitely Cursor or Claude code is not going to be your solution to write solutions to security sensitive edge cases. So services are a great way to sort of take that risk out of your platform. I'm talking about the security risk here, but also that applies to concurrency. That applies to, it's making the risk somebody else's problem.
And for Convex is a lot of very interesting kind of like stuff around like transactions and whatnot. Like, what are some of the things there?
Yeah, I was just gonna say like LLMs are trash at infrastructure. LLMs are really, really bad at distributed systems, and like I challenge anyone to like provide evidence to the contrary. There's reasons why this is the case. One is there is not good training sets out there at all. If you ask me, James, point to a good GitHub repo or a good resource for how to be a good distributed systems engineer, I can't point you at one because there are subtleties involved there that are quite hard to discern and capture. And they're not subtleties that are easily captured by evals or repetitious kind of iteration. I think that the challenge with infrastructure is it's about conceptual clarity and simplicity. And I think infrastructural abilities aren't improving in the industry as a whole. Right? I would say they're trending very negatively, to be honest, because people don't care anymore. I mean, it's fine, right? But I don't think there's a tremendous groundswell of people who are like, I want to build the simplest, most elegant distributed systems. Maybe everyone in this room feels that way, but it's just not what people necessarily coming out of school are wanting to do. And a lot of the challenges when building infrastructure is not to build something that works today. It's to build something that scales over the lifetime of a company or unknown workloads, or when someone like 3 years down the track has added 75 more features to the system and it still works and it still doesn't turn into a mess of complexity, right? And so this is a domain, I think, which is still, as of right now, the domain of human beings. And LLMs are great in so many coding applications. I do think I've yet to see them show architectural excellence. And so, great, there's job security if you care about this stuff. I think I could talk for an hour about the things that matter, but I really want to anchor on strong guarantees and simplicity. So, for example, the core building block in Complex is the transaction. Now, I don't particularly like where the industry is heading right now, where people are exposing, say, the database tables directly to the world and using row-level security rules and doing non-transactional queries from the server because, hey, it is easier to get started, right? Because you can be a front-end developer and you can write your SQL queries on your client. But it is not a sound building block because eventually you're going to want to do two things at once. You're going to add a user and also add them to the team and also make sure there's quota in the team and also update the billing system. That's what transactions were invented for, right? And so every large company runs all their business logic on the server in an RPC server that calls begin transaction, end transaction against the database. Application developers don't do that a lot these days because it's hard and because the tools aren't there. So I think the whole point of Convex, the genesis, was like, hey, how about we just put transactions in the hands of the application developer? So you can write your applications as TypeScript functions that run transactionally on the server against the database, and then they will just be correct. You can write race-free code. And that's one thing, where am I going with this? Simplicity is so important, right? Race conditions are one of the most complex things you can experience in any part of engineering, right? So if someone was to say, hey, I'm going to write my code, but I'm going to just do it lock-free and just try to get it right, and no, it's a dumb idea, right? Similarly, when it comes to distributed systems or client-server architectures, right? You want to have strong guarantees. You want to know that the data on the client's consistent with the data on the server.
Yeah.
So I would say if you want to be an excellent world-class infrastructure engineer, you've got to develop passion for simplicity, conceptual simplicity. And that's why Convex exists, because we're popularizing the transaction again, I suppose.
Yeah, and for, I guess, one of the things I kind of wanted to talk about here is like the latest USC Swan outage. I don't know how many people are went super nerd and actually read the entire report, but it was actually somewhat of a race condition, right? You had these specific records for DynamoDB that were, or actually it wasn't for Dynamo, but these specific kind of DNS records that were being set, they were all processed in a queue. Some of the records that needed to be set took way too long to happen, and eventually one of them got deleted, and now you can't access DynamoDB. So that actually caused somewhat of a cascading failure, right? Because DynamoDB is dependent, or people depend on DynamoDB internally at AWS for a lot of different things. So I guess, can you talk a little bit about when you're architecting this kind of system, and you have something you really, really want to rely on, it's very, very useful. DynamoDB is very, very useful. How do you make sure that you have some sort of guarantees in that other system that, if something as core as your database goes down, you have some amount of recovery for it?
Yeah, I think speaking of the two outages, I think there's multiple outages that happened recently. There's one from, I think, Google Cloud also, or was it Azure? Azure went down the other week, yeah. That made me sort of I think there's a lot of value in companies that aren't even building infrastructure products. Maybe you're building an application level thing, but if you're solving these really hard distributed systems problems, like running across multiple clouds, for example. To answer your question, I think running across multiple clouds and having redundancy in a lot of your critical systems is how you solve that problem. But your users don't even need to know that. You should solve those problems so well that when your users, other systems like their Linear or their Slack or whatever, these other big companies' applications are going down for them, and then your application, which is 40 engineers or 6 engineers, is still up and running because you have redundancy in place and you span multiple clouds. That'll speak volumes to them, right? They'll be like, holy shit, these guys know what they're doing, where these other behemoths are kind of failing or flagging or slacking a little bit. So I think that's, yeah.
So is VAPI multi-cloud?
Yeah. We're making that move to multiple clouds. It's harder than I think even we thought. But yeah, yes.
Interesting. Okay. James?
Yeah, I mean, every time there's... Oh, sorry. Sorry, we already messed it up. Sorry.
James Cowling? Yeah,
has to.
James Cowling has co-founder James Turner, right?
Called James, yeah.
Yeah, but I think he's known as Jamie and whatnot, so there's a lot of James.
Your co-founder's name is James also?
Yeah.
Oh, wow.
I think you called it right there. Behemoth, right? That's the thing. AWS is a behemoth. All of the public cloud providers are behemoths, and we're all choosing, because it's expedient, to build on top of these behemoths. AWS in particular, they ship their org chart. The AWS product looks like Amazon. It is a maze of twisty little teams all fighting amongst each other to create overlapping products, some of which depend on each other and some of which compete with each other. So I think there's a few options here. Going multi-cloud is a great option, because then, at the very least, you can hope that the org chart that Amazon ships is different than the org chart that Google ships, which I guess is a good thing. And of course, I will pitch the time-honored classic. You don't actually need to use a cloud vendor. I have scaled many companies by putting pizza boxes in racks, and it's really not that hard if you're willing to pay people to do it. And then you get a totally different set of problems because you have to manage your own DNS. But hopefully the systems you're building are tailored to your product and can be a lot simpler than something that needs to handle every possible edge case for DNS management for 40% of the servers in the world. So
Do you guys do private data center at Spix? Or?
we don't here. Someday I'm going to sell us on it.
Same
And
here.
Tom keeps looking at our AWS bill and saying, wait, why are we spending that many tens of thousands of dollars on CloudWatch?
Yeah.
But, it's obviously a lot easier to go ahead and use one of these vendors that puts every single feature in a box. But literally, I don't think the three of us working for the entire night could name all of the tools that are in AWS. But that's the price you pay, is all those features are in that box. They all depend on each other in ways that nobody knows how they work. It is possible to do things very rigorously. I'm sure somebody out here with a PhD could explain to me how we could do system modeling and talk about making sure that there's no dependency loops anywhere in there. I don't think anyone's going to do that. I think practically these are large balls of string, and the best we can do is try to avoid getting stuck on a single ball. Man, that was a tortured.
I like it. I mean, anytime there's a major outage like this, you'll hear people say, the first reaction everyone says is probably DNS, right? Bit of a meme, right? So why do people say that? Well, I mean, this is all, early Dropbox, you always blame the network team, right? Because they're mostly the bottom of the stack, so it's easy to blame the bottom of the stack. But I think there's a reason why people blame DNS changes. DNS is the domain naming system. It decides how traffic gets routed. People blame DNS because it's a configuration, right? It's a configuration that's actually stored in a text file when you get down to the bottom of it, and it involves emergent asynchronous properties. And so you change your DNS route and something will happen, right? That you haven't tested programmatically. And once it's happened, it's very hard to undo because it's propagating to servers, especially if you did every now and then someone does a BGP route change, and that's the worst case scenario versions. And so I think almost anytime a large, competent, mature cloud provider goes down, it's because of a configuration change, especially when there's wide scale outages. Because if you are smart and have good release discipline, you're probably not going to push a software bug that takes down your whole system. Happens, but you can go through staging, etc. The problem is configuration changes are like a side channel to fucking everything up, right? So configuration changes let you change the behavior of your system as a whole, right? You can change one, and that's why I'm very negative on feature flagging for backend. I mean, we use LaunchDarkly for our dashboard and website and stuff. So we use feature flagging on the front end. I'm very negative within my team, at least, for feature flagging on the back end, at least because feature flagging allows you to change at runtime configurations that haven't gone through testing and that haven't been analyzed. So it's pushing you into corner cases, and you really want to avoid corner cases whenever you can in systems, in distributed systems.
Can we talk about a specific example from Convex that actually is somewhat applicable? I guess this wasn't configuration, but it was more the set of knobs that caused a Convex outage.
Oh yeah, no, I don't remember which one this was.
Yeah.
There's tons of things we've messed up, right? So the first thing I want to say, so we have something called knobs in Convex that you can change these configuration variables and it changes behavior at runtime. These are dangerous. And what was I going to say about that? Configurations. Oh, what I was going to say is, ideally, the best configuration is code. It's gone through code, it's written, it's implemented. And ideally, the best systems are designed so that the corner case is the same as a steady case. And there's I'll tell you later, lots of stories later on about designing Dropbox storage and how you don't want the worst case scenario to look different to the best case scenario. Because the worst case scenario is the worst time for anything to be different, right? You want that to be the simplest time. So,
sorry.
Yeah.
Continue, yeah.
And this is why, for example, Convex is all, I mean, it sounds like chilling, isn't it? I guess I am. But it's all configuration as code. Any auth is done in code. You review it, you test it, you push it out. It's testable. You can have an LLM understand it, right? Much as you can avoid configuration files, avoid configuration files.
You nodded quickly to just worst case and best case.
I was just thinking about something else related to configuration at runtime. I think it sort of goes into the difference between I've worked at big companies in the past, and I'm at a very small startup. It's people having access to production environments, like, and all of the engineers having access to production environments, basically. Like, what do you think about that? Because then they can still change configuration. It's like not audited properly as well. Like that's something we've been thinking about, like making changes, making strides to make it more auditable and like.
Yeah, eventually, you have like all the compliance stuff, and so it's hard, but even at drop off, even at very large scale, when you're talking almost at least 500 million users, yeah, the people had break glass.
Yeah,
you could go and
the
get
core team,
audited.
like the infrastructure team.
Sometimes you got to go get in there, right?
Yeah.
But ideally, almost everything you design systems so they don't need to be configured too much.
Yeah.
I mean, one example is like I'll give an example of the design mistake I made. So we built this big distributed storage system across 3 storage regions, and many data centers within those regions. And this is my decision. It was a bad one. We wanted to have, so everything's erasure coded and stored very efficiently within a region, and we were double writing across 2 regions in case you had a whole region went down, because we wanted to have, I mean, most people don't need this, but we wanted to be able to survive a whole side of the country going down. So we had this erasure, it's very simple, like XOR thing. So you have A in one region, B in another region, and A XOR B in the 3rd region, right? So normally you can just read A or B from one data center, but in worst case scenario, you have to read from 2 data centers and reconstruct it. That seems nice in theory, right? But under steady state, there's hardly any additional cost because you're reading from one region. But what happens if that data center gets overloaded? All of a sudden, you have twice as much traffic in your network, right? And if you design a system that the worst case scenario is twice as expensive as the best case scenario, any day that your load exceeds a threshold, you will never recover. Like you'll go into congestion collapse. And that's almost irrecoverable. This will happen with T3 chat, if you remember when we took the app down. Once you go into congestion collapse, it's a very hard situation. Once the load is so high that all you're dealing with is retries and timeouts. And the only solution then is to shed client load and
circuit break.
load them back in. Yeah.
So for actually.
Yeah, I was just gonna add. We were talking about major like cloud outages. I think Google Cloud had a big outage, which had this thundering herd problem. Also, there like one policy change that got rolled out that they then resolved, and then in resolving it, it like caused a bunch of like the service came back online, and just like a bunch of traffic started flooding in, and took it down even more than it had been before.
Yeah. Same with the US East outage, or AWS outage. It's like something goes back online, bunch of like stuff. I think the like first part of the AWS outage caused the second part of the AWS outage, which is like when EC2, which is like all the kind of like servers that you provision, the like very lowest level of server, or I guess like a virtual machine that you provision. It's like once you stop being able to provision those, it's like a very bad day. Do you want to dive deeper into the T3 chat outage specifically for those who?
Can I first say like 3 like unexpected systems design tips maybe you maybe think of?
Go ahead.
1, don't have retries.
Yeah.
Oh, really?
In your system. The retries, almost always, except for rare circumstances, retries should be at the edges, right?
Okay.
Because if something, retries are load amplifiers, right? And so typically, like, if you follow the end-to-end principle, you want to be able to push failures back to the only person who can do anything about them. This is related to the T3 thing, right? When you're overloaded, the only person that can do anything about it is the user. They can go away, or you can block them, right? So there's no amount of retrying inside your stack that's going to help. So typically,
do you want to give a little? Okay, so for a bit of context, there's an app called T3 Chat. Have all of you have used ChatGPT? Please, nods. Okay, good. So T3 Chat's like a ChatGPT alternative. It just lets you select from a bunch of different model providers and models and all that fun stuff. Imagine OpenRouter, but has like a UI client. T3 Chat moved from kind of its like own stack, which was like Redis and something. It was a very weird. I know too much about it. It was a very weird stack onto Convex. As a part of doing that migration, I forget the exact path, but you imagine you like create all these like LLM streams. Convex has like very nice feature where they will index them and give you some sort of way to search them. And I think that is where, okay, now we can get back. So if you imagine, the way that Convex, that a T3 chat user connects to Convex is through a WebSocket. So when you go to t3.chat, and start getting messages, you connect over WebSocket to Convex. That track for everyone?
Yeah. So the worst day of your life as an infra person is congestion collapse. And so you might know what this is, but congestion collapse is under a normal system, you increase load on the system and throughput goes up linearly. You send 5 requests, you process 5 requests, right? And you might think that if the system is able to handle 1,000 requests, when you get to 1,001, it's still going to do 1,000 requests, and you get to 2,000, you're still going to do 1,000. Like it's going to cap out. But almost no system caps out. Almost every system collapses. So once you issue more load than the system can handle, instead of just doing the best it can, it just completely fails. And for a variety of reasons, but typically that's because the server takes so long to process those requests. By the time they're being processed, the client doesn't care anymore. They've timed out. So the server's good put, the rate of doing good work drops to 0. The server's spending all its time doing retries, which you ordinarily should not have inside your stack. All this buffering. You shouldn't really have many queues inside your system, to be honest. Queues depends on the scenario. Like you shouldn't have too much buffering because buffering makes requests last longer, right? The longer a request lasts, the more resources it can take up, the more likely it is to time out and waste a bunch of time before return to the client. And so this was a situation where, there was a bug. Let's say it's all our fault. And Theo had this huge number of clients in a retry loop because of how the app was built and because of how things work on the server. They were just giant DDoS cluster just sending us requests over and over and over again. Now, fortunately, it was only taking down his app. The rest of the Convex was fine. But that's a really difficult situation. And it's much more messy than that, but Convex is designed pretty well. So we were able to get this under control by ultimately blocking ranges of clients and scaling it back up. And it's a long story, but this is just that's a bad day when you're getting too much load that you can handle and everything drops to 0 and you just can't make it stop. And I've had to deal with that so many times. And it's 3 tips. There's 1, no retries inside the stack, most of the time. 2, no queuing inside the stack, most of the time. You want stuff to fail, then it's most of the time. Obviously,
James, once. Do you have any thoughts here?
I'll let him finish.
Okay. Once it sticks, it has to receive real quick. The scenarios are different. Sure. The third one is a weird one. Is if you do have queuing inside your system, typically it's a FIFO queue, first in, first out. That's the normal way of having a queue. Under extreme duress, large companies with very sophisticated infrastructure, like Facebook or Google or Dropbox, will switch to LIFO. We'll switch to processing the queue in the reverse order, which seems like a very weird thing to do. And the reason for that is if the queue is long enough, by the time something gets to the front of the queue, it's too late. That request has been going too long. That user's navigated elsewhere. The service that called you is timed out, right? So once you're collapsing, at least do something. At least process some requests, because then maybe the load will go away. So if you switch to LIFO, you can at least process some requests fast. It's not fast, it's not fair, but at least you're making some progress. Yeah.
Okay.
Sorry, I'm on call.
James is also on call.
Yeah.
Are you on call?
No, not today.
Lucky. Yeah, I mean, obviously that's right, but the thing to remember is most systems are not large, and most systems will never undergo any kind of collapse. And when they do, it'll probably be because somebody ran select for update on the entire table and now everything's blocked unblocked. So there is a tension between following these best practices, which are, I agree, if you're building Facebook, you should build it that way, and building something that can handle scale in an agile fashion and can handle small outages without enormous complexity. So I can give an example. When I was at Uber, actually, we had a very big project to get rid of retries. And the solution that we had come up with to get rid of retries was to issue every request twice. So every single internal request would be issued in parallel twice, and then which they would race, and whichever one returned first would be the one that worked. This is extremely elegant. This is great. Here's the thing. It requires double provisioning everything, and it makes all of your systems much more complicated. People are absolutely going to screw up the logic for managing idempotency across 10,000 services. It is elegant, it is beautiful, it is correct. It is 100, that is better than retries. I absolutely agree. But I also understand that there's no way that you can take thousands of newbie engineers running tens of thousands of code bases and get them to actually execute elegant patterns. And it turns out to be a lot easier to just over provision your servers enough to handle retries and have enough global circuit breakers and have enough compensatory patterns that sometimes the elegant thing isn't what you need to do to scale the company. Sometimes what you need to do to scale the company is the gross, ugly thing of, okay, well, it turns out that things in this data center drop 10% of packets, so we need to retry across those, and we're just going to have to hammer on it until it works. So there's that tension between like doing the right thing and doing the pragmatic thing that's always hard to find.
The funny part about this is actually how I believe like Red Panda and Warp Stream like work is that S3 has like very high like tail latency for certain things, and so you just like do it twice because eventually like S3 will. Red Panda is like a like kind of. How many of you are familiar with Kafka? It's actually very. Okay, sick. Okay, this is a very good audience. So if you've heard of like Red Panda or Warp Stream, they're kind of like serverless Kafka, and they like flush all of their events down to S3. And when that flush happens, they just like sometimes send that request twice because again, you don't like S3 doesn't have a guarantee of like, hey, this request will only take max 250 milliseconds or something like that. Sometimes it just like takes a lot longer, and so you just like send that request twice, and then you get like a better guarantee there. I'm sure you guys know a lot more about why exactly S3 has that kind of weird pattern, but that's did not have time to research that. So I like your point, James. Brown, Mr. Swix, Mr. Brown today, about sometimes the kind of like best thing to do is like not the most elegant, scalable, or sort of the most elegant thing, but the thing that like scales your company. Do you all just have like more thoughts about like things that you've put in place, like guardrail specific patterns in your code bases, just to like help the company scale and like help the people scale, versus just like the most elegant thing for the system?
I was just thinking, like, from what you both were talking about just now, I feel like we're flirting around kind of the concept of multi-tenancy also. And I think it's really great that at Convex, for example, Theo like took down his own client, right? He didn't negatively impact other people on the platform. Which there's obviously the case where maybe you have like a huge growth day and a bunch of people just sign up for your platform, and you have a bunch of traffic come, and then you need circuit breaking, and maybe you need to avoid retries. But I think doing like relatively simple things like having rate limiting in place, like at your load balance, at your API gateway, to make sure one person cannot just like hammer your system, and also just like having things in place to protect users from themselves, because like we bill based on usage or minutes on our platform, and we don't want to just let people like accidentally run up their bills on our platform. So having controls in place, like user configured controls, but also like system level limits in place to prevent them from like screwing over other users on the platform, and also just like screwing over themselves is really important. And I think it's both pragmatic and a little bit more simpler, maybe. Yeah.
And then how about like inside of App as well for like your own developers?
How do you mean?
Limits.
For our for engineers at Vappy to develop on.
Yeah, like specific things that you like kind of make sure that Vappy developers like shy away from, because like it's almost like the kind of limits thing that you described, but more for like inside of your system for like maybe.
Oh, when they're developing, interesting.
The thing that like scales the people at Vappy versus the like kind of elegant solution that actually like would is like more elegant inside the infrastructure.
I can't think of a specific example for Vappy developers. I think a lot of like the system level controls I was referring to, like rate limiting for Vappy users, we do at like the infrastructure level. Like no one else really touches like the plugins we use in our API gateway. Like that's stuff that the infra team writes and is strictly reviewed, obviously. So yeah.
I kind of want to defend the word elegant, but I think we all agree on it.
Okay.
Yeah.
But like, I absolutely agree that you should not take, you should not base your infrastructure on Google and Facebook. Google is terrible role model on how to design systems, because they're designing for Google scale, and they have a bajillion engineers. And by the way, Google biases a little bit too much towards being clever, right? Google a little bit skews towards like, hey, we've got to move off of, the old version of F1 that ran just fine on Spanner because you gotta, right? And so, I mean, I think one example of this is Kubernetes, right? It's way too complicated for almost anyone. outside of a major company. This is what we got. We use Nomad at Convex. Probably should have used Kubernetes just because it's more popular, but I think it's largely horrendous. Like, it's just so complex for almost anyone's use case, right? So yeah, I mean, you should not cosplay as a multi-trillion-dollar company, and you should not over-engineer things. And so I think like we all agree, but I think like just in terms of the word elegance, I would like really argue like the simplest thing is sometimes the most elegant thing. Like, for example, like the storage system at Dropbox, when we built it, had about 3 exabytes of data over 1 million hard drives. It's a massive system, right? It costs almost $1 billion. And the index that stores like where all the blocks are was just a really big MySQL cluster. It was like 256 MySQL clusters, times 3 reps, right? Which was like the most stupid thing you could do, right? But it worked. It was just a giant table that said, it had a couple of columns. This block is on this machine, right? Just super simple and very elegant. It wasn't cool. It wasn't impressive. And every time someone would join the company, especially if they've come from like PhD program, they come, I was one of those people too. But like they come and say, "Oh, that's silly. You should use a Patricia try. You got to use a distributed hash table that does a thing." Like, and yes, you can come up with very complex, sophisticated, maybe they would call it elegant, but these are not good solutions. You've taken something really basic and understandable and just works. And by the way, you can just run a validator. You can walk over the table and see where the data is and see what's meant to be. And trying to replace it with this rather complex algorithm that has emergent properties, and you can't walk over a distributed hash table and see if all the files are where they need to be. There's no record of what blocks are even in the system, right? So absolutely, people should do this simplest. So I think being clever is bad, but like being smart is good. There's a definition there, right? Clever is like, I was gonna stereotype really bad, but like, like MIT kids, right? Again, I was one of them, but like people who come out of school and they're like, yeah, I'm gonna do the coolest, most sophisticated thing, and I read all the papers, and I'm gonna solve this problem with this algorithm, right? That's clever, but it's not smart. Like smart is like, well, we don't need something fancy, so just do the simple thing, right? Yeah.
Yeah. What are, I guess, like across the panel, like what are the things that you've like done at big companies that are simple like that, like not terribly clever, that just are also very easily applicable to like someone building a startup that right now has 100 users, and next year all of your startups will grow very quickly. It has like 1 million users.
Sure, I'll start. The old advice is the best advice. Take the pieces of your application that are stateless and separate them from the pieces that are stateful. Take the pieces of your application that can be batched and separate them from the pieces of your application that need to be online. Like, everybody knows this. This is obvious. This gets banged into you anytime you talk about things. But then you go out and look at real applications, and it's like, oh, here's our, one Node.js application that does all of our client serving, and also some of the requests that hit it take 30 seconds and hold open a database transaction the whole time. And also some of them require 10 terabytes of RAM because they load in an entire, like, decompose your application into the pieces as best you can that have different behavioral properties. And then you can look at each of those and figure out how to handle them. So again, to give an example, like at Uber, we weren't great at this, but we had all the real-time pieces, which were everything that the drivers and riders on Tripper interacted with. That was a completely different team. That was a completely different infrastructure than billing systems, which those were batch oriented. Those were all behind a queue. You know why? Because nobody cares. If the billing screws up, if the billing is behind, whatever, it's billing. It can happen later. That can all be a totally different kind of discipline than the real-time pieces. And that can be different than the analytics. Not like decomposing your application. I know like monorepos and just having one big application, it's very hard to separate this concept of one developer stack from one deployed application, but really there are these different disciplines around the different things that your application can do, and being cognizant of that and thinking about how to best optimize them early before you end up in the position where your one Node.js application is constantly ooming because somebody is sending large batches to it. I've never regretted that, and I don't think any of you will either.
I had a question for James, Convex James. So you like called out Kubernetes as being like overcomplicated and people maybe jump to it too soon.
Yeah.
But at some point you need to make that hard choice because everyone is super ambitious, right? Like we all want to think that we're building the next $1 trillion company.
Yeah.
So you want to be making choices that eventually scale to, and even if it's not a $1 trillion company, like you want to scale to millions and millions of users on your platform. We want to scale to like tens of millions of calls on our platform. And Kubernetes seems like the best tool for that. Like when do you make that choice to switch from Nomad, for example?
So I don't. I mean, it's a good point. Like you never want to paint yourself into a corner, right?
Yeah.
So I think you want to like structure the evolution of your architecture in these stepping stones, right? That get you towards where you want to go, but are as simple as they can possibly be without closing the door or anything, right? I don't think it's that hard to change the containerization framework because we've done it multiple times.
Yeah.
You know, now at Dropbox early on, 2012. 100 million users, I think. Code push was SSHing to every machine in a for loop and calling HG pull, whatever the mercurial command was to sync code down. It was Python, and it was just the source code was literally just running on the machine, and you would just like do a git pull basically and live. And sometimes, by the way, you'd have a merge conflict in production because someone had SSH to the machine and they had changed some code to fix a bug, forgot about it, and then you see these failures because there was a merge conflict inside the Python code, right? Now, sure, you wouldn't do that in 2025.
No, we have Vercel.
But in 2012, I don't know, we're fine, right? And so there are some things that I think are hard to change. And excess complexity early on is hard to change. I mean, I'm still on broken record. Not having transactions is hard to change. Building very tightly coupled systems where you can assume that you can always run a transaction on every single thing at once, hard to change. Because what's hard to change is when you accrete complexity and all your developers assume that every operation they can do can access every other service. And so that's stuff that's hard to change.
Yeah.
Changing container. Now, that said, I'm just being bitter. I just wish, say, Kubernetes wasn't the standard and something simpler was. But no judgment if it is standard, so whatever, go use it.
Yeah.
But I recognize when those things don't need to be that way. Like there's no need for almost any company to like, oh, I want to start a blog, better spin up kubectl and like, like you don't need that.
Yeah.
When did you guys make the decision to like? Did you always start on?
We've been using Kubernetes.
Yeah,
we've been using Kubernetes since day one. I think the example that comes to mind in terms of like overcomplicating things is when it comes to our database, we've tried out a couple different database providers, and we found like we were on one database provider who I won't name, but like they were
Wasn't us.
They were trying to reinvent like connection pooling. Like they just didn't want to go with PG Bouncer, and like PG Bouncer is fine. Like it works. Like why reinvent that? And so that's when we realized like, okay, maybe just going with very simple vanilla things that don't seem super flashy for something as critical as your database is the smart choice. That's something we learned early on about a year ago.
That is. Yeah, I guess not to name it. I'm very surprised like a multi-tenant connection pooler exists.
Yeah.
But yeah. Actually, I'm very curious for Mappy specifically, is it like Kate and like multi-cloud because like you just get a very nice spread across regions and across LLM stuff, or is it also like very good for reliability? Like
reliability, cost, capacity also we can burst onto like multiple regions. Like the capacity hasn't really kicked in yet, but like we're expecting like that amount of traffic, or like we're preparing for that amount of traffic. But cost is also a big mover as well.
Is database still in one place or
database in one place?
Okay.
Yeah.
So not bringing any like fundamental.
No, not changing that.
There is also one thing I think you meant.
Oh, I have so many things about to say. Yeah, sorry.
Okay. Okay, I'm actually curious what those things are.
Yeah, so it's okay to go down. I mean, maybe it's not okay for Convex to go down because like we're a back-end platform, and if we do, like a lot of people are unhappy. But for most companies, it's okay. Like if Amazon goes down for like 2 hours every 6 months, which it's actually not that bad. It's probably 2 hours every 18 months.
Amazon.com or AWS?
AWS.
But like, there's critical things that run on it. Like look at the airlines when the Azure outage, like airlines couldn't like.
You know how airline systems are written? There's no backups or failovers anywhere in that stack, and they can double issue tickets. There's no consistency, and if they get it wrong, they just give you a free ticket. And they decided that is cheaper.
I did a project for MD's travel once. I can rest assured it's a little bit more complicated than
You've got more comment, yeah. So these systems using the is it called RS? No, what's the old Fortran systems?
Or at Amadeus?
Amadeus and the other one as well.
Yeah.
Sabre, yeah. There are certain scenarios. So anyway, maybe it's not our systems, right? But
Yeah.
for a lot of folks, it's okay. So for example, I speak to a lot of small companies, young founders who are like, I'm going to build a multi-master distributed database. I need to have it, right?
Do that.
And that is an extraordinarily complicated thing that almost no company has, by the way. Some might, but certainly none I've worked closely with have done multi-master distributed commit because it's slow and it's complex and stuff. And so my answer is just like, I don't know. If there's a network partition and the whole of the United States is split in half, everything else is down too. So that's okay.
Well, where does that line, I guess, stop? I think AWS, that USC1 outage, very, very exceptional. Like I said, when you cannot provision an EC2 node on AWS, that's a very, very bad day. But then what is the kind of line of okay, external providers going down too much, your auth providers has been down too much, time to switch. Where's that line?
Well, I think durability and availability are very different things,
Okay.
right? You lose, for many companies, you lose data, that's the end of the company, essentially, right? It's so you need to have replication across regions and backups and all that kind of stuff. That should take it very seriously. Most companies don't have multi-master replication. They just, it just goes down if the region goes down, right? It's always nice to deal with your own availability with someone else's, right? And so if you're working with third parties, typically, and other James had already said this, I think, but you want to have these decoupled systems. Ideally, these systems aren't tightly coupled so that someone else's availability doesn't deeply affect yours. So if you can have an async job pushing stuff to your billing system, don't write to your billing system the critical path of your requests, right? If something doesn't need to be in the live path, take it out of the live path, right? Yeah.
Oh, do you have anything, James Ryan?
Yeah, I mean, I think we're all talking about this from a technical perspective and ignoring the thing that really matters, which is the reason you make these decisions is all social. You don't ship Kubernetes because you deeply care about using gRPC to talk to your provisioning system. You ship Kubernetes because you want to hire people who use Kubernetes. Or you ship Kubernetes because you've decided that you want to empower development teams to have a radical amount of control over what kinds of things they can deploy. And that's the choice that you actually need to think about as an infrastructure person, is what the social pieces should be. The exit is down the stairs to the right.
Yeah, exit down the stairs to the right. So if you, yeah.
Sorry about that, everybody.
I forgot to announce that. Yeah, when you don't leave, you'll go outside that door to the right and then down the stairs. Yeah.
So, as infrastructure people, what you actually need to be doing is talking to engineering leadership about what the social constraints of your company are before you make any of these choices. You talk about multi-master databases. I can tell you at EasyPost, we actually did that. Every single system was backed by a Galera cluster, which is a multi-master replication plugin for MySQL, not because it provides higher durability or consistency, but because we had one sysadmin, which is me, and it provides greatly reduced labor for the system administrator team if you can just take down a server without causing downtime or without having to do a complicated reparenting operation, which even in these days of GTIDs and MySQL is not a free operation. You don't make that choice for technical reasons. You make that choice for social reasons, and you need to be thinking about those social reasons every step along the way, because if you try to dictate technical solutions, your company will never succeed. If you come in and say technically this is right, or technically this is too complicated, or technically this, what's going to happen is, well, you'll probably end up with a new CTO on top of you who will hire a whole separate team that will do something a different way, and then you'll have two companies and it'll be a giant mess. The social parts are inescapable, really.
And we might have different definitions of multi-master, but yes, absolutely, you should have replication so you can fail your database automatically, yeah, absolutely.
Tejas, I guess that I was going to ask that question, and like, anyway, like, what are the things that at Vappy, like, kind of tech stack wise, or just general, where you're like, okay, like, if we, use this language, it like makes it a lot easier for us to hire, like those kinds of things that are a little bit more like social infrastructure wise. That you think.
Yeah. I think Kubernetes is a big one. Like we want to hire infrastructure engineers. It makes it easier. Kubernetes and distributed systems, I think, if you're looking for people who are good at distributed systems, they usually have experience with Kubernetes because like it has become kind of a standard in the industry as well. TypeScript, because I think a lot of people have familiarity with it, Golang for a lot of our infrastructure services as well, and then PostgreSQL because of that seems to be very popular nowadays as well. I'm not totally I can't confidently say like I can say that we haven't made these decisions thinking like, oh, it's going to make it much easier for us to hire things. I think it's just like happens to be the things like my whole team is familiar with are also the things that a lot of the industry is familiar with too, right? Because these things are standards for a reason. Like a lot of people have worked with them. A lot of us come from like big company backgrounds or even other startups who have worked with the same stack.
What about for like newer tools? Like I'm not sure if Vappy has an internal model for this, but there's like some internal kind of like voice detection models that you use, like detect when a user stops speaking.
Oh yeah, like endpointing, things like that.
Yeah.
Well, again,
The question is more like those are kind of like very unique parts of the stack. Like how does like the team get trained up to like run those things? Like what are the ways that you just like start gaining experience to?
Oh, interesting. I wouldn't say like the Vappy employees necessarily need to be trained up. Like we're integrating these things on behalf of our users, and a big like part of like Vappy's ethos are sort of developer first, right? Like we want to give the Vappy users as much choice as possible in the system. Like on our platform, you can use any voice model that you want to use, any transcription model, any LLM. Like we try to integrate new models like the same day that they're released. The same goes for endpointing models. So like DeepGram Flux, I guess, is an example of a transcriber that has endpointing built in. So like we had that integrated within like 2 days of release.
And then like what's it like kind of like integrating those into like the Vappy infrastructure and backend? Like how is it to like operate those kinds of things? It's like a ton of different models that come out. Do you like host a model and then it's like, like we learned a bunch of like these things and now we like need to go.
Yeah, I guess it depends. Most of these integrations, like we've built it so that it's easy for them to plug in into the voice pipeline easily. I guess every now and then there's like a new model that has like maybe a kind of a unique interface that we need to tweak our pipeline. Like we sort of learn from that, like, okay, we need to like loosen this coupling a little bit or like make it a little more abstracted so we can just plug this thing into it. Yeah.
And then James Brown, I think you have some experience doing like, I think MySQL version upgrades as well. Like what is that kind of experience is like for a team, like learning to operate some new piece of technology?
Yeah. Learning to operate a new piece of technology is the whole job, right? Mm-hmm. That's either you keep learning new pieces of technology or your misfortune to become a manager. So it's really hard. Like you have to do it as a person. You have to sell it to your organization that it's important. I think here at Spix, and for anybody who may have come to our Rust meetup last month, we're in the process of migrating all of our analytics to ClickHouse, which is a technology that we haven't used internally before. So it's like both developing the operational expertise to run it and training everybody else in the company, like how do you use it? How do you write queries against it? How do you structure your data to load into it? It is super important. It is also really hard to budget against, well, okay, do we spend some time doing training on how ClickHouse projections work, or do we spend some time fixing these user bugs? I don't have a great answer for that, except to say that I wish I could get more time on the former. But yeah, that is, I think, the cost with the degree of infrastructural complexity that you see at companies nowadays. Once upon a time, you would be like, okay, I'm going to go write software. It's 2007, so it's going to be LAMP stack. So I need to know Linux, Apache, MySQL, and Python. And those are the only 4 technologies I will ever use. And if I get really big, I'll have to learn Memcache. And now, like I was saying before, you use AWS. You have 500 different services. And if you have a team that lives long enough, you will end up with somebody somewhere who is relying on them. And you do have to make sure as you make your decisions that you're thinking about those social aspects and thinking like, okay, it is easy to bring on this new feature by saying that I'm going to use, some new service for it, that I'm going to implement this new endpointing feature by using this API. But part of the cost is paying for the API, and part of the cost is that you have to train people on how to use it. And it's really easy to forget the non-technical part of those costs, which I guess that's my theme for today, is just to be the guy who like constantly is the downer about the non-technical costs of infrastructure.
Yeah, I'm pretty down on data-driven decision making. I think maybe I don't hear it this much, but there was a big wave of everyone would put on their resumes data-driven decision making, and that was the big thing. And it seems good because data-driven decision making seems like, oh well, I can eliminate bias from my decision by using data to decide. Now, data is great to evaluate the success of a decision in hindsight, but data is pretty bad at deciding something for you, because ultimately your intuition contains a whole lot of inputs, many of which are not measurable, right? And so if you're making a decision purely based on, so for example, like, who can I hire to manage the system? Do I trust the team? Do I have a good relationship where I can negotiate? Are the features come out? Is the API clean? These are things that are not easily measurable, and you could make up measurements for it, but that's just making up measurements to cover your ass, right? So typically, if you're choosing a database or a framework or something, and your decision is you're going to try 5 of them and benchmark them all and pick the one with the highest throughput, you're probably going to make the wrong decision. And so I think there are engineering cultures where people are afraid to make decisions, and those companies tend to make bad decisions. I think ideally you hire good people, you have good values, you have high standards, and you use data to see if decisions went well, and you obviously have to keep your eyes open. But yeah, you make calls and you use your intuition, you use your judgment, and that's great. And also engineers are happy when they're doing that stuff. Typically, some people need to be encouraged to feel comfortable putting their ass in the line. But yeah, I think exactly like stuff like, can you hire people? Is the team going to like using this? Is this compatible with what we do? That's oftentimes more important than something very quantifiable.
All right, as one last thing, because we're coming up in just an hour, I've actually heard from a fair amount of people that hiring is extremely hard right now, and for 2 reasons. Like, first being is the kind of existing like lead code style interview, especially if you do it remotely. We're kind of coming out of the remote era with COVID. You just still do a remote interview. Now you have someone using Interview Coder, and they just ace the interview, congratulations, and then they fly out or something like that, or you give them an offer, and then they actually, I completely forgot. You have a story. Were you guys the company who, like, your first engineering hire or something like that, or one of your engineering hires was like Soham?
Soham,
yeah.
I think so. I was before my time. But yeah, apparently we got
Anyway, yeah, it's like someone who just like did a bunch of like interviews, and he was doing way too many interviews for companies. Anyway, so that kind of has changed. Like, people are just now evaluating your ability to use AI tools, and now there has to be like a new class of interviews for doing system stuff. What do you think the kind of like future direction, or how do you guys do like hiring this like new era of things? Like, what are you guys like mostly looking for? And are you hiring? You're allowed to do a CTA here.
Yeah, we're hiring. Yeah. If you're an infra person or you're a TypeScript expert, let us know. Again, I care about judgment, and so we don't do any sophisticated hiring. We don't do any AI anything. I mean, obviously our engineers use all that stuff for their job, but I don't think AI fluency is particularly important to be an engineer at Convex. Everyone can figure that out. It's not hard, right? So what I care is whether someone's able to think well, and they got good conceptual clarity and mentally agile. So I still do whiteboard interviews, and on coding interviews, but it's not like, hey, let's see how well you use Claude. I mean, personally, I think it's dumb. I don't know. The best person using Claude's not going to be the best engineer. And pick the best engineer they can figure out Claude. It'll be fine. So we do that. We just do old school interviews. And the absolute most important part of the process is every engineer interviews someone, and then we have a debrief meeting in person, and we all talk about the candidate and share whether we think there should be a hire or not. And that's the meeting in which everyone has to own their decision, and everyone learns what everyone else thinks. And that's an iterative process. So the more times you've interviewed and the more debriefs you've gone to, the better you get as an interviewer, because interviewing is an art. And it takes a long time to get good at interviewing. And I think the debrief is part of that.
Are there any particular like startup specific things, or is it just like that entire process? Because you're such
Down the stairs to the right. I'll figure it out.
Yeah. I mean, I obviously want people who like have some hustle, have some excitement, and want to be there. Yeah, but beyond that, yeah, passion is important. Yeah.
next round.
Spix is hiring. If you're interested in webhooks, if you're interested in web services, if you're interested in writing Rust code, please come work with us. There's the mandatory pitch out of the way. I'll answer this in two parts. First, hiring software developers. It's impossible. It's a total nightmare right now. Yes, there's the AI stuff with constant cheating. Also, the market is just totally fucked because there's been all these layoffs at big companies. There's a ton of people who are seniors who have been on the market for years and are like very desperate. I can't imagine what it's like for new grads right now because there's so little trust because everybody's cheating all the time by using these terrible AI tools. And also the market is full of this glut of senior engineers who have been laid off by big companies because executives got enamored with these AI tools and thought they could replace all the seniors. Hiring software engineers is very hard. We do it here at Spix. We do it with a combination of take-homes and interviews. Take-homes are really rely on trust, right? Because an engineer can obviously choose to cheat at it. And so it's about talking to the person first and trying to get a handle on their personality. But frankly, it is an incredibly difficult problem. And if somebody solves it, I would be ready to beat down your door to find your solution. Hiring infra people is way harder. Like I just said, it was impossible to hire software. Hiring infra people is harder. I've been doing interviews for infra people for 15 years. It's never been easy. It's gotten steadily harder. I think a big part of it is that the pipeline is tiny. When I was in college a long time ago, part of how I got my start in this job was doing system administration work for the college. That was something that people were interested in. Hell, probably half the people in here grew up playing with Linux on an old 486, right? But that pipeline is gone for infrastructure people. My college doesn't even have a system administration team anymore. And I talked to new grads from my college, they don't even have a mandatory systems class. They don't have the interest in that like lower level is gone. And the pipeline I see of like new candidates to do infrastructure is very small and tends to be very buzzword driven. So you get people who like, oh, well, we did a class on AWS and I can just go on AWS acronyms. That's not what you're looking for. You're looking for somebody who has good intuition. You're looking for somebody who has like systems thinking and can figure out how to decompose a system without invoking any buzzwords, ideally. And that's, again, it's very hard. I think maybe we just need to take the top 3 gigahertz off every CPU and send everybody back to the dark ages for a while to see if it like, there is something about the like working in the constraints, right? Having to figure out how to work with systems where you can't just get a petabyte of space from S3 and never have to think about how your storage works. So hiring for infra is hard and it requires talking to people. In my whole career, I've done a lot of different kinds of interviews. Airbnb used to do this absolutely terrible interview where they would give you access to an AWS environment where they'd like broken some things and have you write a bunch of like CloudFormation templates to launch things in it and fix things and then talk. And it was like, no. Like you can't make an objective measure of how good somebody is thinking about infrastructure. You just need to talk to them, and it's long and it's labor intensive and it requires following up on this pipeline. And that's sort of a dismal answer, I suppose, but you just got to grind away at the work. And I think we have good people at Spix. I think I've worked with good people in my career. I hope there's some good people in this room, and you just keep grinding on it until you win.
So we're also hiring at Vappy. If you like working with highly distributed systems focused on real-time, very low latency, let me know after this. We're also looking for security engineers if you are a security engineer or know security engineers in your network. I'm going to change the tune a little bit. I actually think hiring in some sense has gotten better. It's definitely harder in some ways, especially for the remote interviews. We're a very strong in-person culture. We're like 4 days a week in person, 1 day is hybrid. And our interview process is this. It's a remote coding challenge, optional system design remote if needed. You come on site and it's like 4 hours. There's 2 system design interviews we do in person. I love whiteboarding with new folks. I think that's like the best way to figure out how people think about really, really complex problems. And then it's offered. It's like that simple. And then you're working with us in person and like you can't fake that. Like it's gonna be very hard for you to have like Cluely open on your computer 24/7 while you're like in a room with us designing a new project. I think the other part that's like gotten sort of easier about hiring is I feel like SF is back in a big way. Like I think the AI boom, like a lot of people just really want to work at really like hot young AI startups right now, and they want to be like kind of feel that rush. And maybe this is what it felt like back in like 2000 or like 2008, also with like Facebook and everything. But yeah, I think that's also made it better. I would say the harder part is probably like filtering right now. Like top of funnel feels pretty good, but then like filtering down to the candidates you really want to get in is tougher. I think there's a lot of like AI recruiting tools now, and I imagine like on the other side of it, there's also a lot of like AI applicant tools. So I don't know how much that's complicating the pipeline.
It's all horrifying.
Yeah, it's like AI's talking to AI. So
Well, it's also all the AI hiring tools are, measuring people's skull shape to tell you whether they're going to be a good fit at your job. They are horrifying from an HR perspective, and you should not use them.
yeah.
Don't chat GPT your resume. I mean, you can ask it if it's any good, but don't use it to write it, because if I'm reading 100 resumes in a row, I promise you I can tell. Because you can tell. If I gave you 50 ChatGPT things in a row, you know the sentences, right? Yeah. And I would say, what percentage of them? 50%? Or more than 50%. 70% are written by ChatGPT, or Claude, I suppose, but you can just tell. And they just blend together. I just can't tell the difference. And so that's tough. It's like an arms race. And I don't use AI to evaluate resumes. But maybe I'm going to break down because I can't. It's getting hard to keep up.
Okay. Don't use Delve in your resumes. Be a hot AI startup, it seems. I guess.
How do you evaluate your cultural fit? Or to ask it another way, have you ever hired someone who seems like good technical fit, but he could not cope up with the culture?
Yep.
Did you have to fire him?
Yep.
I had to do the same recently, so I wanted to understand like how do you pre-evaluate your culture?
Yeah, I mean, in-person interviews helps a lot. And we actually do an all-around interview where you ask a bunch of questions about challenges you faced and stuff. I mean, it's never nice to terminate someone, right? But also the culture is so important. Like if you let that go at your company, that's it. Not all the people that you want to be there aren't going to want to be there anymore. So yeah, sometimes you get it wrong, but I think you can get pretty good at testing enough in-person conversation.
We used to do work pilots at Vapi also. Like you would work with us. That's actually how I came in. I worked there for like 3 days on a trial basis, and I just like never left. It doesn't scale well, obviously. Like once you're like start interviewing people every single week, you can't just like have people come in, add to your code base, and then leave after a few days. It becomes like kind of tricky. But I think in person is definitely like the way to go to figure out if someone's a cultural fit. And have them talk to as many people on your team and in the company as possible when they're on site with you.
And panel diversity, really important.
Yes. Yeah.
I, at one point, a couple of companies ago, had a candidate where they had perfect fives, must hire from everybody except the one woman on the interview panel who said that they said awfully sexist things to her the entire time. Would we have known that if we didn't make sure that our interview panels had, people representing different sexes and gender identities and races? Probably not. And that, since then, I've seen that several times. Never with the case where it was perfect fives from all the men on the panel, but like, you definitely will have this as a problem, and it's if you don't think about it early, then you'll end up being the place where everybody's in the locker room all the time.
James Cowling, I think. Do you have an event to run to?
I do.
Okay.
Yeah.
I'll let you go. It's also we're like almost out of time, but does anyone have like questions generally? Okay. James,
I'll hang a little bit longer. Yeah.
Cool.
I have a question.
Sure.
What is your biggest crack moment that you had while scaling your system, and how did you not mind completely lose your mind?
Well, to me, the hardest thing is always data, because data has inertia. Data's heavy. It takes time to copy it from one place to another place. If your data's in the wrong table format or it's inefficient or your underlying database is something weird, it's going to take you time to rebuild it. And that's the hardest stuff that anything's stateful. There's too much to say about this other than you gotta have fun. You gotta joke. I mean, you gotta have a zero blame culture. Like when something's broken, it's never anyone's fault. It's like, what's wrong with the system? How do we solve that? And there's like gallows humor that develops. I think that's fine. Like even as like CTO of my company, I'm okay that people are making jokes about downtime because you gotta. I remember Dropbox had a massive outage. Dropbox was down for 2 days, and as soon as it went down, someone said, "Good thing my resume is not in Dropbox." And I don't know. It was funny. I think that's fine. I think you gotta you can't be all doom and gloom. You gotta yeah.
Yeah. I think coming from a big company to a startup, I really learned how to sort of roll with the punches kind of. I think my arms are probably covered in burn marks now. You just learn from the fire at a startup too. I think the oh shit moment maybe was being woken up at 4 a.m. for our DB being down first of all, and then 2 weeks later we had API degradation because of high latency on our database queries as well. And that was a 2-day fire we were fighting. And I was sweating at first, and then I was like, okay, we can learn from this, we can get better. And then now it's not so bad. Both because we're more stable now, but also because I know how to deal with the issues a little bit better in probably a healthier way.
Do you have a database that has planet scale?
Not planet scale, no.
I would say planet, but a planet scale database. I don't know.
No.
Bob's cut this out of the video. I'm not sure if we're not on the show. James.
Another pitch, real quickly. I haven't had any of these fixed. We haven't had any big oh shit moments yet, which is sort of amazing. And I think it's mostly just luck. So, knock on luxury vinyl planks. But I can tell you that it's really about knowing the system and being comfortable with it. And I'll tell you a really quick story. I was at Uber in the early days. I think I mentioned this. Uber does much of their traffic on 2 to 3 days of the year, which is Halloween, New Year's Eve, and if it's a Friday, St. Patrick's Day. To the degree of seeing 10 to 100x traffic in some cities on those days in the beginning, because it's a lot of drunk people getting a lot of cars and then sitting in them for a long time while they're in traffic. So one year we were scaling up our systems to handle this load, and we had just rolled out a whole bunch of new network gear. We were moving from a layer 2 to a layer 3 network, and we had all this beautiful layer 3 intelligent switching, Juniper, SRX hardware. We also had terrible software design that in some cases relied on sending enormous numbers of 10-byte UDP messages. And it turned out that we actually hit a bug in Junos where doing certain policy-based routing, once you passed about 600,000 packets per second on an interface, the switch would crash. We hit this bug at peak time on October 31st, 2013, which is not a good time to have all of your switches crash. But thankfully, we knew the system. We weren't dealing with a morass of vendor stuff. We knew exactly how to reconfigure to route back through the old Cisco switches, and were able to basically hot rebuild the network in about half an hour. By all being there and all having the people who knew exactly how everything worked, and having people who had all the intimate details of the system in their memory. Because if you have to go look at a wiki to figure out how, you're not going to do it. You're not going to be able to deal with the shit. It's 9 p.m. Pacific, midnight Eastern on Halloween, and the system's down. So it's just be prepared and have the people who can help you in the room already, and it'll be much less of an oh shit moment than if you have to wake them up in the middle of the night.
Yeah. I think there's a question back there.
Yeah, so double tap on the work trial question. It seems like it's super popular in startup scenarios, especially in San Francisco. I think it's made famous by Cursor, the one-day trials. And are you guys fine off work trials? Any plans to try it out, or are your guys like bad taste?
We did it for a while back. Like again, that's how I joined a year ago at Vappy. But then we stopped it once we realized it just doesn't scale well. Like someone needs to be managing the work, the person who's piloting. We're also very against the word trial because trial sounded like kind of cheapening the work experience. We always called it work pilot. Anyways, but yeah, like someone has to manage those people. So it's like it doesn't scale well when you're like bringing like several people, like more than 5 people on site in a week, right? And also like how long are they going to work on it? What project are you going to give them? What's going to happen to the code they wrote after they leave? So on and so forth.
I think it's really easy to think you're good at recruiting if you have the fastest growing startup in history, right? Because you can do fucking anything and people are going to come work for you, right? I love the Cursor guys, so that's not a critique, but like, I just don't think anyone should look at Cursor as a role model. And look, if you have a company too that's making hundreds of billions of dollars, millions of dollars, whatever, do whatever. You can afford to be a bit, hostile in your recruiting process. But if you have a regular company, you're probably not going to survive too long finding people who were willing to come and work for you for a week and then make you lose their job straight afterwards, right? It's going to select for a very specific kind of person. And look, if you're a young startup looking for hustle culture, like 996 kind of people, and they're all 22 and they have no commitments in life, then you probably can pull it off. But if you want to hire someone in their late 30s who has been working on databases or whatever and has a family and needs to make money for that family, and taking a job is a pretty serious thing for them. I know it's a big ask, and I get I think it does something to you. I mean, firsthand. So I feel like it probably does something to your culture too.
Yeah, it includes a lot of really good
people is coming in and doing some work and they're being evaluated. It creates a certain kind of culture.
I agree. Yeah, that's another reason we stopped it. It also, to your point, precludes some really good talent that's like just not with trying a work trial, right? Like they hear that we're like coming in and working for 3 days with you, and they like sort of they don't want to do that, and then you don't get that person in.
Or they're relocating. I guess they can fly out. There's always answers for it. I just think it's
also like, how many of you have started a job and been at your best within 3 days?
Yeah.
I don't understand that concept at all. It takes me more than 3 days just to figure out where in the code base things are. Like,
I had a
nonsense.
work trial this year where it was on my personal laptop and the code base was like breaking my personal laptop, and I was like, hey, can I get a laptop? And they're like, nah, can you use your personal one? And so just like 2 days of me just being like, man, this hot refresh is taking 3 minutes on Next.js. It's like, this sucks. Shout out, I guess, like Better Turbo, like back or whatever is good. But yeah, it's like pretty hard to ramp up that quickly. Some people can, but like, yeah.
That is the other piece there, which is that doing work trials requires operational excellence in IT, which no startup has. Practically, a lot of the places that do it end up with a long trail of accounts that never get shut down from people who are on work trials, and a long trail of checkouts of their code base, which probably has all the secrets in a .m file checked into the root. Come on, let's be honest. That never get cleaned up. So you can do it. We don't do it at Fix. We have tried it in the past. We do not do it. I think the cost of being able to onboard and offboard a ton of people with a lot of churn is way higher than people are willing to admit, or they just aren't willing to do a good job of it, which is equally likely.
Some people make it work. They're targeting a certain kind of person who likes that kind of thing, and they're targeting a certain kind of skill set that you can evaluate in a week. That's not what I'm looking for, but yeah, good luck to the folks who are. Yeah.
Great, thank you.
Yeah.
Alrighty. I think that's it. Thank you.
Thank you.